Measures of dispersion. Why dispersion? To know how far spread out the data is. One way to do this is through the range. This is the distance between the high and low values. The maximum value minus the minimum value. It uses the extremes. The bigger the answer, the larger the spread of the data. A special instance of this is called the interquartile range. This is the distance between quartile 1 and quartile 3 and takes up the middle 50% of the data. A second measure of dispersion is the standard deviation. This is the average spread from the mean, and it's a nasty formula. You're going to take the square root of the mean of the square deviations, whatever that means, and the bigger the answer here, the larger the spread of the data. So let me show you whatever that means. In an example, the X are my data pieces. I need the mean to come up with the standard deviation. The mean here, add 10 plus 8 plus 6 plus 4 plus 2 and divide by 5. Mu equals 6. In the next column, I subtract X minus mu. 10 minus 6 equals 4, 8 minus 6 equals 2, 6 minus 6 equals 0, 4 minus 6 equals negative 2, and 2 minus 6 equals negative 4. If I add those all up, I'm going to get 0 every time. So I square them. The deviations from the mean squared. 4 squared is 16, 2 squared is 4, 0 squared is 0, negative 2 squared is 4, negative 4 squared is 16. Now I can find out the average amount of deviation from the mean. The formula for the population standard deviation is seen at the top right hand of your screen. I'm going to plug in mu. I'm going to plug in sigma, meaning add, all of these deviations squared, which is 40. And I'm going to plug them into the formula at the top right of your screen. Sigma of x minus mu squared is 40. Capital N for population, there were 5 pieces of data. So I'm looking at the square root of 8 for my sigma. It's about 2.8. When I do the same example as a sample, I'm now looking at x minus x bar because a sample mean is x bar. The numbers remain the same, but the formula in the right-hand corner is a little bit different. I take my sum of the deviations squared, which is still 40, and I plug it into the formula, but in this scenario, because I have a sample, I have a small n, which was still 5, but I subtract 1. In other words, you're taking the square root of 40 divided by 4. N, or approximately 3.16. A little bit different when we think of the information as a sample. Excel will always think of it as a sample for you. In Excel, we have a printout or output, which is assuming a sample standard deviation. Standard deviation here from that same problem is 3.16. At least we know we got it right. The range, maximum minus minimum, is 8. To use descriptive statistics, Office 2007, go to Data. On the far right edge, Data Analysis. Click on Descriptive Statistics and OK. Input your range. If you want it to come out into a new sheet, shown at the bottom, you could click OK now. If you want it to be seen on the same sheet, click Output Range. Click on the box, click on where you want it, and make sure to click Summary Statistics. Okay, and there it is. Trying some more in Excel, because who really wants to do those by hand if we can use Excel or some other statistical package? We punch these into Excel, and in example 5 with these numbers, the measures of dispersion for standard deviation, 14.78 to the nearest hundredth, and the range is 46. Using another example, typing those numbers into Excel, standard deviation 11.46, and the range, high value of 85 minus the low value here of 53 is 32. Now you try one. Whatever version of Excel you have, type these numbers in, go get the descriptive statistics, and find the standard deviation and range. Pause the presentation here. Resume after you have completed the problem. Your answer printout should look like this. Standard deviation of 8.75 to the nearest hundredth, and a range of 26. Now try another one. Put all the pieces together. For central tendency, mean, median, and mode. For dispersion, range, and standard deviation. They all come from Excel and descriptive statistics. So type them into Excel or another statistical program or your calculator and come up with the answers. Pause the presentation here again. Resume after you have completed the problem. Your printout, mean is 77.5, median or middle number is 76.5. The mode, there isn't one. Standard deviation, again, Excel gives you the sample version of that, if you happen to have calculated by hand, is 15.87, and the range is 49.